Now, the first part of a significance test is stating the hypotheses. There's two hypotheses. There's a null hypothesis and the alternative hypothesis. The null hypothesis is a statement of no effect or no difference or no change from historical values. So we assume that there's no change from what we our previously held idea. Now, the claim about the population that we want to find evidence for is the alternative hypothesis. So in our paramedic example, we uh, we had the null hypothesis of 6.7, but we wanted to see that there were improved times. So our alternative hypothesis is that it was less than that. Now we write the null hypothesis, H with a subscript of 0 or O, uh, and the alternative hypothesis is H subscript A. Now we always define the mu that's being addressed in the problem. So we write these in terms of mu or p, and then when we're done with that, then we write what that actually stands for. And that'll make more sense in a little bit. So in the paramedic example, let's find the null hypothesis. So our H sub now that stands for our null hypothesis. So our null hypothesis is that our mean is equal to 6.7. And I'm just going to write that. Now our alternative hypothesis, that's an A, is that our mu, we wanted improved times, so that would be less than 6.7. So once we have that, now we have to define what mu is. So I'm just going to write mu, and now I'm going to type so you can read what I'm writing better. Mu is the mean response time for paramedics after the encouragement. Now, we know that the x bar, the sample, is less than 6.7. But if we generalize to the whole population, are all of the calls going to be less than 6.7? That's the thing that we're checking. Now, hypotheses always refer to the population and not a particular outcome. So we want to make sure that they're in the parameter. So make sure that's a mu instead of an x bar. Now, alternative hypothesis can be one-sided or two-sided. A one-sided, like we did there, was either greater than or less than. We could also do a two-sided hypothesis, and instead of less than or greater than, we do not equal to. We do a two-sided hypothesis if we don't know the outcome of the study. You're doing a study and you don't know if you should check the upper end or lower end, so you have to check both. Here's an example. Does job satisfaction of assembly workers differ when their work is machine-paced rather than self-paced? One study chose 18 subjects at random from a group of people who assembled electronic devices. Half the subjects were assigned at random to each of the two groups. Both groups did similar work, but one work setup allowed workers to pace themselves, and the other featured an assembly line that moved at fixed time intervals, so the workers were placed by machine. After 2 weeks, all the subjects took the survey. They switched work setups and took the survey again. The parameter of interest is the mean of the differences in the scores of the survey. Now, this asks what method of design did they use. This one is a match pairs design. Since each person did the first method and the second method, they can take each of those values and subtract them, and then have one list of the difference of the values. So what is the null hypothesis? So in this case, what we have here, we have a null hypothesis that there's no change. So first, let's define our mu. Mu is the difference in in survey scores between the two methods. So that if mu is the difference, now let's think about what the null hypothesis is. If there was no change in those differences, if they're exactly the same, mu would exactly equal 0. Now, the alternative hypothesis, we don't know which method is better. We have no idea starting if it's machine pace or pacing themselves, so we can't say mu is greater than 0 or less than 0. We just say mu is not equal to 0. All right, those are your hypotheses. Good luck on your own.